at least from a brand perspective, we're an Australian-based but multi-region buy now, pay later business. Started in Australia in 2000 and I'm going to test our onboarding material 2014, 2013, 2014, thereabouts.
Yeah, 13, I'd say, if I think so.
Yep. Normal consumer finance type products, but expanding into wallet and business products. I think we'll stop there in terms of the business context, but that's a little bit about who Zip is. In terms of international points of presence, we're in Australia, New Zealand, UK, US, Canada, Mexico, UAE, Czech Republic, as of today, I think, and South Africa, I think. I'm sure that there might be one or two that we're missing, but that's where we are globally. Our implementation of Snowplow at the moment is focused on the Australian market, but we're obviously having conversations about expanding that into other regions.
Righto, let's get into it. So take it away, Schmidt.
All right. So there's a lot, like there's a canvas that accompanies and describes what our data platform reference architecture is. But for the sake of today, we'll constrain it to the parts that are directly attached to or relevant to Snowplow. We've obviously got Snowplow and related trackers on the client side of things. That's basically our giant data machine. From an extraction perspective, amongst other tools, we've got Fivetrain on board. We're currently evaluating Airbyte for an internal equivalent. Not exactly the same, but considered an equivalent. DBT from a transformation perspective in favor of Scala, Python, Spark jobs. The strength of that is that it's SQL as a first-class citizen and doesn't need the breadth and depth of Spark plus Scala knowledge from an engineering perspective. We onboarded Snowflake as our data warehouse roughly at exactly the same time that we implemented this. There might have been a few days difference, but so that's a recent addition to our technology stack, and there's a lot of very nice hand in glove as we go through this technology stack. Then on the consumption side, this is more about once it goes through the machine, how do we make it accessible to the analysts, data scientists, engineers, and other product teams within the organization. Historically, we use Amplitude. It's a bit of a spaghetti bowl mess, but the intent of this is to clean that up in terms of cleanliness and reliability of data. Pablo from a business reporting perspective, and Full Story in terms of that complementary capturing the user journey to accompany the analytical data as we go through at a high level. There is actually a lot more to our technology stack, but for the sake of today's discussion, we'll limit it to that. All right.
Do you want to take this one?
Maybe let's tag team on this one.
Easy. So I'll talk a little bit about the start of, like, I guess, some of the decision process in the Snowplow side of stuff, and then I'll pass back to Schmidt to talk through a bit more about the nuances of some of the Zip decisions that were made around how we deployed it. So we evaluated quite a few different options in the kind of event collection, I guess, group of software out there. It seems that there's quite a lot of things that kind of extend into it. Like you could kind of say, look, Amplitude, Segment both extend into it, but Amplitude's more on the primary side of the visualization, Segment's more on the primary side of sort of moving data around. So one of the aspects that we really liked about Snowplow was the really highly opinionated way it was kind of just event collection on that point. So that ability for us to enforce really high quality data structures was super appealing. It was a problem that we'd faced in a lot of other areas, I guess, over the history of Zip, where, you know, someone might define a customer in one way in one event, define it slightly a different way in another event. So that ability for us to have these shared contexts in our Igloo schema registry, be able to share those was really, really appealing. Basically meaning that we can just spend our time on, you know, maintaining a single good version of an object rather than trying to maintain sort of a whole bunch of different versions of one object somewhat poorly. The scalability side was super appealing to us. And I think the community side was another aspect that was pretty appealing. When we kind of went through and evaluated a whole bunch of different areas of our stack, at the same time, as Shruti alluded to with the Snowflake coming online at a similar point in time. One of the aspects that became quickly apparent was you can kind of chop and change a bunch of the stacks, whether it's like the data warehouse component, the event collection component, the data transform layer, but there's like some pretty common patterns that just make life a lot easier. And Snowplow and Snowflake seem to be one of those patterns to us. And finally, the open source nature was really appealing to us in terms of not having to worry about how many events you send to an event collection platform. That was massive. And it was another one of the driving factors in the decision.
Yeah. In terms of how did we take it and make it our own, again, kind of piggybacking off the community side, and we run the open source installation internally. We deploy it on AWS EKS with the Kafka backbone. I think that one of the early conscious decision points as to why would we run it ourselves is that the underlying infrastructure that enables this to run very well and very reliably was already in place. So we already had an EKS cluster in place and in a number of environments, and there's an engineering team pointed at maintaining, curating, and operationalizing our Kubernetes installation. It's not something that we as a team need to maintain ourselves, so that was good. And by extension, Kafka as the backbone was critically important. One, because it was supported out of the box. Two, because it was something that we were already running. So we've got Kafka as a capability pretty much across the almost entirety of the platform, I'd say. But again, it didn't take too much more than a bit of configuration and some automation to make that happen. For us, the relationship between Kafka and the rest of our data ecosystem was critically important. Yes, we could do with Kinesis, but from our perspective, the tools that we wanted to connect into and the services that we wanted to enable are predominantly JVM-centric, so using Kafka just made sense. On the schema registry side of things, our implementation is basically an Nginx container with a directory structure that looks correct with some linking from a CI/CD pipeline perspective. So it's basic, but it does the job. I know that there are different patterns and practices and services and components that are available to enable that through like a dynamic API-based one. But for us, we got the reliability, and the immutability of a schema registry that's version controlled and automated and managed and deployed into our environment the way that we currently do. And it didn't take any more automation on top of that. We took, so Moss mentioned that one of the strengths is that this whole ecosystem is nicely opinionated. In my view, I think that where you're providing an analytics capability, which is general purpose in nature, you need some pretty strong opinions around how to use it. Otherwise, one of the intents I think behind this was to clean up a lot of the mess that we've got with first-party data ownership, where right now we spray it into the internet and try and make sense of it after the fact. If you don't come into this exercise with a nice clean implementation with strongly held opinions in terms of what looks good for your organization, you might be setting yourself up for a bit of a failure. So we took the web tracker SDK and added our own version of what plugins do we install, what plugins do we extend it with, what's the default configuration, what's the just enough for the product teams to make this accessible and easy to implement, rather than expecting them to go to the Snowplow documentation and start from scratch every single time. We've got a fair amount of traction in that way. In terms of the event structure, one of the basic enrichments that we put in place is just using the API enrichment. We take the app ID on ingest and do a sense check against an internal registry of applications. If this is a bit of a protection against junk data, I think externally, but also to stop teams from polluting otherwise clean data. And I think from our side of things, and the meta of this is that we wanted to increase the reliability and trust that the organization has in our data. So we wanted to make sure that we were only capturing, we had multiple environments like most technology organizations do, but we wanted to make sure that production data wasn't being polluted with some dev that's off hacking something, for instance, where it's not being tested, it's not being QA'd, it's not ready for production.
I think just to elaborate on that point for a minute, because I think this one's super important, and it's kind of been useful already. So because we enrich that event data coming through with actual team names, it means that like as an analyst working in say Snowflake on the data warehouse, going, hey, what's this event? You've always got that team name tightly coupled to it. So even if you've got like say page views coming from 10, 20 different front end services, you can still go back and say, hey, this one actually came from this team. And it's been already really, really valuable in us being able to try and make sense of some stuff when it comes through. And hopefully in the future as well, will potentially help us be able to feed back to the team on some of the more operational sides of event volumes and that type of stuff as well.
Correct. One of the things that's in our backlog is on bad event handling. Right now, we just basically push it out to Elasticsearch for just operational exploration, basically. But what we want to do is we don't necessarily want an enablement team to be in the center of 10, 15, 20 or more product teams in terms of good quality data or not so good quality data. So we want to tell the teams directly when their enrichment is or their events are failing in production. Usually it's because of data quality issues. There's no environment like production in terms of test data. So some of the quirks that we experience is where everything is well defined and behaving as it should be, but the reality of production is seeing a property on a context or an event that's missing that should be populated, or the wrong data type where it needs to be a number or something to that effect.
And I think just the last one here, you sort of elaborating on what I mentioned before with like some generic tracking structures. We've already started to see a heap of value with this. One of the sets of tracking structures or data structures that we spent a lot of time on already is funnels, and sort of setting up a core set of events. At the moment, it's composed of 4: a funnel start, a funnel outcome, and then we break funnels into sections. And again, we've got a section start and section outcome. So due to the composability nature of all the different contexts that we build out, this means that we can actually have the same underlying data structures for the funnels for, say, an acquisition funnel or a checkout funnel. And especially once we start getting into more complex visualizations around funnels where you can go through loops, skip steps, etc. The time that we spend on doing the data processing for those funnels and those visualizations, it's pretty portable to other funnels. So, if we go out there and decide to instrument another funnel with the same set, all the data processing layers that we've already got in place for the most part are really nicely transposable.
Okay, so I think Moss has already kind of touched on the how do we use it. And at the moment, we've got it embedded in our mobile app. We've got it embedded on the Australian region web properties. This isn't ready for multi-region just yet, as I alluded to earlier, but for right now, we've got it in, I'd probably say the majority of our main customer journeys. So the ability to sign up, if you're looking at the website, and when you're going through an online checkout and in the mobile app. So those are the main points of presence. Obviously, there's more gaps to fill, and the business value of being able to link one particular journey to another, even though they're disparate applications, is something that we're just starting to realize now that these applications have been in production for quite a while and there's more and more coming on board. So you're getting a better visibility across teams in terms of how it all hangs together. So it's a little bit of the how we're using it. We didn't really cover that in terms of the material here, but these initial challenges are ours, to take the quote from Full Metal Jacket or a version of it. There are many like it, but this one is mine. This is my gun. There are many like it, but this one is mine, I think is the full line from the movie. But anyway, so where you're running the managed service, I think these are probably not as big a deal, but these are some of the initial, I'll say challenges. They weren't really even hurdles because they were ultimately solved within a week. We didn't really go back to basics and revisit a lot of the major decisions we made. The first point, I was just thinking about qualifying this just before we started the presentation, is that the tooling is fairly rudimentary if your implementation, assuming you go the self-hosted route, right? I think a lot of this is entrenched in that. The tooling is fairly rudimentary unless you exactly mirror the way that Snowflake runs their hosted solution.
Snowplow.
Oh, sorry, Snowplow. Damn.
It's going to happen once.
Sorry, it's going to happen at least once. Apologies. Yeah, if your implementation differs in any way from the way that Snowplow very consciously runs their operation, our observation is that the very generous open source ecosystem takes a bit of work to make it work, or to come up with your own equivalent for some of those capabilities, particularly like shredding raw event data into semi-structured information in readiness for your data warehouse ingest. One of the things that was a pleasant surprise, I'll say, was the explosion in volume. So initially, we just had it in one very small place in our mobile app, and I think in a single release, a very diligent and keen engineer went and put it everywhere. And it was an exciting day when that app really started hitting critical volume in terms of users. So that was a lot of fun. It was less of an operational problem in terms of the ability to service the inbound events. As a point of reference, even though self-hosting, we get a ridiculous amount of performance out of not very many pods running in production. I think it's worth calling out. This is a very, very well-performing system that we don't really need to nurse too much. There's a couple of beginner questions to this point, and I need to thank Mike for his very patient answers to some of this, to some of these questions from time to time. But you know, as you're building out your operational dashboards, and you can pick your Datadogs or New Relics or whatever you like to monitor this stuff in the back end, getting an appreciation of what normal event behavior looks like it takes a little while, but there's obviously like load moments that go on. Like a good example for me is watching the collector good events versus the enricher good events, and the delta between the two in terms of event volume is something that we monitor. Seeing a line between the two had me concerned for about an hour, at which point I hit Mike up and said, hey, what's the deal here? And he said, well, you know, one event in the collector actually usually results in multiple coming out the back end on the enricher side of things. So just taking the time to understand it within the machinery and even within your own ecosystem, what that looks like, it's interesting, I'll say. When you're self-hosting, you're subject to the general internet and also your corporate governance and security controls. So there's a little bit of work that goes into filtering out that noise. Most recently, we had someone reach out to us from our web team and say, hey, Google bot seems to be chewing up a lot of our allowance on your particular endpoint. Can you look after that for us, please, so that we can spend that budget elsewhere? You know, it takes a tiny little amount of fine tuning, but I think that as far as the noise reduction or the signal to noise ratio, I think is much better now than it was initially. And this one is probably a big one, and this is where it's a journey, not a sprint. Is really unpicking your current assumptions of what's true and your current implementations, where your goal is to have a scalable and modern data platform where you may have a litany of tools or legacy or absolutely nothing in some cases. Unpicking that legacy where there's lots of strong opinions that are entrenched within teams about what good looks like, and basically taking them on the organizational change to a company that is an adventure in its own right. And then just working across those teams to make sure that knowing what the change is that's necessary, hopefully with enough legwork done to make it really simple for them, but just working through the transition plan and executing on what that looks like. Those are some of the initial challenges that we've gone through. There's probably a couple of others but those are the main ones.
Right, so I guess sort of wrap things up, I think it's probably important for us to talk through a little bit about what kind of happens on the back end of this, because I suspect this is possibly where a lot of people's implementations differ. I imagine the sort of event definitions and context definitions is one area, and then the sort of processing side of it. So in essence, the top section here is basically what our data warehouse in Snowflake looks like. We're split into two databases, Prod Raw and then Prod Analytics. So Prod Raw is effectively the landing zone for everything on a schema division. So Snowplow's got its own schema in there. along with any other system that we're pumping raw data out of and into Snowflake for. So our data processing layer of DBT doesn't have any write access to that layer. It's entirely read-only. But where the fun stuff happens is in the prod analytics database. So in this one, instead of dividing by source system schemas, it's divided by kind of the level of processing that's happened. So we start with prod source, which is always a one-to-one mapping of our raw data in the layer there, just with PII redaction done and naming conventions enforced. So there's every naming convention under the sun is used in some part of some third-party system that we use or some internal system. So that prod source layer gives us a really good opportunity to standardize that. And DBT is responsible for maintaining those source mappings. Then the sort of, I guess, engine room of the analytics stack is in the prod prep layer. So that's where we do our deduplication. So we start breaking out common transforms and do a lot of the sort of lead work underneath. And then finally, we're materializing assets that are basically designed for consumption by a specific system in our prod mart layer. So, you know, extracts or live views that are meant for Tableau, views that are meant to be, or materialized tables that are meant to be loaded into Braze, for instance, for segmentation, that type of stuff is what lives in prod mart. And it's, I guess, really important to call out that DBT is really fundamental in this stack. I think, and it's been a great help to us throughout this. So a lot of the things around being able to enforce testability on those data structures. So we've got all the events going to one common table, our Snowplow event table, basically. And that's obviously quite sparse for all the different event types coming through. But once we're able to break out specific event types, we can then enforce the structural integrity of them on the processing side with DBT. So making sure stuff isn't null that shouldn't be null. If we're expecting to have relations, for instance, with other data sets like our customer tables, etc., we can enforce those relationships as they come through. And then finally, the documentation side of stuff. So it's one thing to have, you know, all our schemas well documented at the sort of Igloo schema level, so that when we're reading it and we're making changes, that we've got a clear understanding of what the intents of all those contexts and event types were. But this also allows us then to basically enforce documentation standards on all the layers of processing. So if we come back to a process that was defined on a certain Snowplow event, you know, 6-12 months ago, we can go through and read the documentation to go, oh yeah, okay, that's what this event field was for, or that's what this event type was, or the event name was sort of intended to be used for. And this is, again, one of those things that we enforce from the get-go. It's impossible to push a model into prod prep or prod mart without having full documentation done on it and full, at least one unique test on a column and at least one not null test on a column. You can override them if you absolutely need to, but by default, those are enforced. And it means that as we do grow and bring more people on into the team to work on this, we're able to maintain a really high standard of documentation and also data quality from those tests.